Hey, welcome back. And I was just going through some interview questions, and I saw that one of the most popular asked questions was like Fibonacci, like they'll tell me the nth Fibonacci number or something. And I thought, okay, let's make a video about it. And today I'll show you not one or two, but five ways to actually calculate the Fibonacci number. And the four of them are like actual coding way, and the fifth one is math heavy. So I'll not directly go into the math. I'll just give you the formula, and you can research a bit more on that. So let's directly get on with it. First, I'll tell you what Fibonacci number is. So consider you have uh, the first two numbers will already be given like 0 and 1, and each consecutive coming number will be the sum of the previous two numbers. So after 0 and 1, the next number will be 1, next will be 2, which is the sum of 1 and 1, next number will be 3, which is the sum of 2 and 1, next number will be 5, which is the sum of 2 and 3, and so on. Yeah, that's basically what the Fibonacci number is. And now let's code it up. So let's define a class. And there is no need for any initialization over here. So let's code the first web. And since I'm inside a class, I have to have self over here. And let's take the value to which we have to calculate. And yeah, this is the direct iterative way to calculate the Fibonacci number. So what you have to do is initialize the first two values. So a comma b will be 0 comma 1, the first two values. And for I in range, since you have the first and the second value, so you have to go from 2 to value minus 1. Don't forget, this is mainly because of zero based indexing. If you go till value, you will get the n plus 1's value. You will get the n plus 1's value. And again, I'm telling n plus 1 based on 0 base. Okay, let's do with 1 base indexing only. So let's go from 2 to the length of 2 to the value itself. So and now just think about what you have to do. You have 0 and 1. So you have to add them up to get the next value. So let's look at for, yeah, let's look at what you have to do after you get 3 and 5. So you have to add 3 plus 5, which will become 8. And yeah, you have to first add the values to get the coming value. So a plus b and store it in some value. So some yeah, and don't call it sum and all because sum is an actual method in Python. So let's call it temp. So after you get 8, what you have to do to get the next value? You have to add 8 plus 5. So we can actually forget about 3. So in other words, a is now a is actually pointing to 3 and b is actually pointing to 5 and temp has the value 8. So what you have to do now? So a should actually become 5, b should actually become 8, and temp, well, temp goes away. So let's do that. So a should actually become b and b should actually become temp. And yeah, that's all it. After that, you can return b, which will contain the nth Fibonacci number, and a will contain the n minus Fibonacci number. So let's just check it out once. Let's look at the fifth Fibonacci number. And fifth number is telling us 3. So let's check it. Let's just look at it once. So 0, and then you'll have 1, and then you add 0 and 1 to get 1, and then you'll add 1 and 1 to get 2, 3, 5, 7, and so on. So, and the fifth number is first number, second number, third number, fourth number, and fifth. Yeah, and fifth is coming 3, which was actually the expected result. And yeah, that's one way to code it up. It's an iterative way, and I is not being used over here, so we can just replace it with an underscore. And now let's do the second way, which is actually using dynamic programming. So what dynamic programming tells is that rather than computing the values again and again, you can compute the actual value from the previous values itself. So let's do it up. Again, we'll have self over here and the value. And so what you have to do is now consider an array which will have the 0 and 1. And now what you have to do for since you have the first two elements, so again for I why we are doing 2 over here is that it is 0 based indexing, so 0 and 1 will like already be calculated. So 2 to value. So what you have to open? You are actually at 2 So you want to get the next number 3, which is the sum of the top two elements. So let's add the top two elements and add it back to the itself. Yeah, and this is how you actually get the top two values in Python. Now you can directly return the array at the position -1, which is the top index. And yeah, let me just print out the array also for you guys. Fibonacci is way two. And yes, as you see, you are getting the actual value, which is 3. And you are already also getting the Fibonacci numbers up to the nth number also. And if you wanted to do the same in the first value, then after calculating temp, first you have to actually add A and B, and after calculating temp on each part, you have to append that to the array. And now let's go for way 3. This is the way 3 is actually like a pure recursive way of calculating Fibonacci number. And it's I recommend you to like just code it up once and tell them that it's not time efficient as it takes 2 to the power of n, where n is the number of elements you are searching for, like nth Fibonacci number. And obviously, you don't want any kind of 2 to the power in your solution, as that is very bad. So let's just code up the recursive way also. Again, you'll have self and value. And so what you have to do, if n is equal to 0, if no, it's not n, if value becomes equal to 0, then you know that the answer is 0 because 0's Fibonacci number is 0. So you'll directly return 0. And if value becomes equal to 1, then the first Fibonacci number is 1. So 1. Or you store the values after doing this. What you have to do is you have to store the actual values of n minus 1 and n minus 2 in the recursive stack or the memory stack. And after computing each value, you have to pop those values from the memory stack itself, and that automatically the computer or the compiler will do for us. So there's no need to for us to especially do that. So you can directly return the Fibonacci way 3 of value minus 1. The because n Fibonacci number is n minus 1 plus n minus 2. Since I'm calling it inside a class, I have to put self over here. And then with that, add the self dot Fibonacci way 3 of value minus 2. And yeah, one thing to note is that this will give you the n plus 1 Fibonacci number if you are considering zero based indexing. So yeah, just be careful about that. No, just print it out. Since I told right, like you will get the n plus 1 Fibonacci number. So to get n Fibonacci number, just reduce it by 1. And as you see that you get 3. And I will show you why this is not a good solution. Imagine you want to calculate the 35th Fibonacci number. And what happens when you run is that you will see that to calculate just the 36th number, it's taking a lot of time, and my computer is also overheating. And yeah, my computer actually became a jet engine to calculate this number. But but when you do the same thing using the above two methods, you see that the result is actually instantaneous. That speaks about its complexity, yeah. And yeah, it was 34 because you are actually calculating the n plus 1 value over here. So let's make it 34. And as you see, you got the result instantaneously. But when you try to do it using pure recursion, the time was like really bad. You try it out, you'll get to know. And so now what can you do is that there is a technique called memoization, using which we can actually improve our complexity. So rather than yeah, let me just show it to you. Okay, now okay, let's not look at this now. Fibonacci recursively, let's look at that. And yeah, let's look at this tree over here. This is the cool looking tree. And so you want to calculate the sixth number. To calculate the sixth number, you actually need fifth and fourth number. So let's to calculate fifth, you need fourth and third. To calculate fourth, you need 3, 2, and to calculate 3, you need 2 and 1. So what you'll do is first you'll calculate 1, and then you'll calculate 2, and then you'll calculate 3 using 1 and 2. And to calculate 4, you'll calculate in 3, calculate the value of 2, and calculate the value of 2 and 1 again. And but what happens is for 5 again you will do the same thing. But when you come to this side of the recursive tree, you see that again you have to fib of 4, And what will happen is that again it will calculate the entire part. This entire right subtree will again be calculated. But actually you have already calculated it once. So what you do is you store that value somewhere. And I think the best thing, that one thing should come to your mind when it comes about storing and retrieving these hash maps or dictionaries. So what you can do is after computing the value of 4, you store it in a dictionary, and then directly and when you're computing it again, just check if you have computed the fourth value, and if you have computed it, then directly return it from the dictionary. Get that value from the dictionary. You can do like that. So let's code that up. Fibonacci, this fourth way now. Again, so again the same thing. If value becomes equal to 1, then return 1, and if the value becomes equal to 0, then you return 0. Or else what to do? Now do the checking part. So if the value is actually present in the dictionary, and what this does in Python, what this does is that it will check if dictionary is there, and if dictionary is not there, it will initialize the dictionary. And the dictionary is already present, it will not re-initialize it, but it will actually use the dictionary itself, like the computer dictionary. So value exists in the dictionary. So what you can do is you can directly return the dictionary at the position value. Or else what you have to do is, so for dictionary at the position value, and it is actually the self dot Fibonacci wave 4 of value minus 1 plus the self dot Fibonacci wave 4 of value minus 2. And now you can return the date position value because the value of the nth value will be stored in the nth position of the dictionary. And now let's just print it out to check. Again, this will give the n plus 1 Fibonacci number, so be careful of that. Fibonacci wave 4 of 36. So you have to put 35 over here. And as you see that you got the result instantaneously, but when you are doing the same for when you do the same for the recursive method, you'll see that it will take a lot of time. And now, believe it or not, there is one more way. This is pure mathematical way to do that, and I will not go into the crux of it. I'll just give you the formula. It's better you just check it out once. So it mainly uses the theory of what you tell. Okay, I forgot what it is called. And now, since this is actually a computing course and not what you tell math course, I'll not go much over it, but it uses a theory, a technique called golden ratio and all. If you know what a golden ratio is, then you will understand it. Fibonacci wave 5, which will actually, so what you have to do is the actual formula is, first you will have a value called 5. 5 is actually 1 plus this again pure mathematics, 5 to the power of 0.5, which is the root of 5, and then you will divide it by 2. This is actually the actual value of 5. And what you will do is that you will return 5 to the power of n or value, and you will divide it by 5 to the power of 0.5 again, which is root of 5. This is the actual value. This is like pure math. So if you want, you can just check it out once. I will not like go over why the formula works and all. And yeah, you are actually getting the nth Fibonacci number. Let's just round it once. What round will do is that if it is above 0.5, it will take you to the above value, and if it is below 0.5, it will take you to the floor. And yes, you see that you are actually getting the correct answer. So now, if anyone asks you about how to code a Fibonacci number in interview center, you can tell that I know 5 ways to do it. Yeah, that will obviously impress anyone, and you can code these ways. I think the most simple, the really simple ones are like this one, and yeah, if you have the capacity to remember stuff, and then you can directly code up the actual formula itself. And if you want to like impress your interviewer and like show them that you actually know stuff, then you can code it in the recursive way using memorization. That will obviously show them that you have a good grip on basics of computer science. And yeah, that's basically it for today. Thank you. Stay tuned.